Alright, so looking at a couple examples here. First of all, let's start with one that's in a polynomial form here. Okay? Here we want the solutions to 2 sine squared of x minus sine of x minus 1 equals 0 in the interval from 0 up to 2 pi. Okay? So we have this polynomial form. We know it's a polynomial form because sine is squared. And typically to solve polynomials, we set it equal to 0, like it is. And then what do we try to do?
You either factor it out or use the quadratic to find the zeros.
Okay, you can use the quadratic formula, or if you can, factor it out. Factoring is faster if you can see it. All right, so let's go ahead and practice factoring this one. So how would we factor 2 sine squared minus sine minus 1?
Sine minus 1 and 2 sine plus 1.
Plus 1?
Yeah.
Okay, you guys agree with that?
Yeah.
Okay, if you're not sure, remember you can test the outers and the inners. Alright? We have different signs, so we are going to get the minus 1 at the end. The outers will give us a plus sign. The inners give us a minus 2 sign. So 1 sign minus 2 sign is negative 1 sign, like we want. Okay? So double checking there, you're factoring. You can check the outers and inners. Okay? So now, in a polynomial, once you had it factored, you knew that either the one set of parentheses had to equal 0, or your other set of parentheses had to equal 0. Alright? In order for them to multiply together to equal 0, one of them had to equal 0. So now you have basically 2 of the types of equations we were doing yesterday, where you're simply getting sine by itself. So here's sine equals 1, and according to the unit circle, where is sine equal to 1?
Oh,
90.
Yeah, 90 or pi over 2. Since it's asked us for an interval in radians, we'll give our answer in radians. So pi over 2. Okay? How come we only have one answer? Because there's only one answer?
Yeah. Because of the interval.
Yeah.
It's like if you have sine of 2 pi plus 1, then that'd be greater than, like, just because, like, I don't know, the way you, like, visualize it, you can just tell.
Well, yeah, but
Because it's
even in
positive.
0 to 2 pi, usually we'll get like 2 answers, right?
It's
Where is sine positive 1?
Oh, because it's only in the first and second quadrant, and the 90 is in both.
Okay, the 90 is that quadrantal angle right between the first and second. So it's actually both, counts for kind of both quadrants at the same time. So that's why we're going to get one answer in this case. Alright, so we have that, or here sine would equal negative 1/2. So now where is sine equal to negative 1/2?
Third and fourth quadrants.
Third and fourth quadrants. Our reference angle is
I have 3.
pi over 6.
Yeah.
So pi over 6 in the third quadrant is
7 pi over 6. And
good, 7 pi over 6. And then in the fourth quadrant it's
11 pi over 6.
there we go, 11 pi over 6. Very good. Okay? Now here's the nice thing. They've actually designed all the problems, unless they tell you that you need your calculator, they've designed all of them to be unit circle based problems. So you really don't have to use your calculator for any of them. Okay? We will do some that you have to use the calculator for, but all of these ones, practice using your calculator, or not using your calculator, practice using your head in the unit circle. The more you do it, the more comfortable you'll get. Okay, so any questions about this? Alright?
So that would be our answer, x equals pi over 2, or x equals... We
Yeah.
have to make it x pi over 2 plus 2 pi n, or would that only if it asks for the general?
Only if they ask for a general solution. Here they ask for the interval from 0 to 2 pi, so you don't need the plus 2 pi n thing. Alright, so now let's take one extra step here, and here we have one that again is a quadratic form, but we have different trig functions. So here we have the equation 2 sine squared of x plus 3 cosine of x minus 3 equals 0. So now we actually have to do step 1 in our process. Okay?
Reduce somehow change the sine squared to a cosine squared.
Okay?
Cosine squared plus 1.
Yeah, how would we get sine squared to be cosines?
Cosine squared
Plus 1
minus
That would be 1 minus cosine equals sine squared.
There it is. Okay. Sine squared is 1 minus cosine squared. So we're going to substitute that in. Be careful with that algebra, because if you don't plug in the right thing, obviously you won't get the right answer, but that also can make things really messy. So if you need to, just real quickly, sine squared cosine squared equals 1, do the algebra real quick for yourself just so you can see it. That'll help you avoid making a little mistake like that. Okay? So now everything's in terms of cosines, and we're back to what we had the previous problem. Okay? So we have 2 minus 2 cosine squared plus 3 cosine minus 3 equals 0. Once I combine like terms here, negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. What would be helpful to do?
Bless you. Multiply all by negative.
Yeah, get rid of the negative there. It's always easier to factor if you've got a leading coefficient that's positive. So if I do that, that, and that, since that's 0, I can do that. I'm just factoring out a negative 1, or you could consider it dividing everything by negative 1 to get rid of that negative. Okay, so now I have positive 2 cosine squared minus 3 cosine plus 1 equals 0. Okay? Now we're to the point where we can factor and get our final answer. So you guys try taking it from there. Okay? Try factoring that and then finding your results. Okay. What does this factor into?
What's the motion?
2 cosine minus 1 cosine minus 1.
You guys agree with that?
Yep.
That work out? Okay, good. We get the plus 1 because they're both negative. We have a minus 2 cosine, minus 1 cosine. That's a minus 3 cosine. Alright, so good. That's all factored correctly. So, as a result, I know either the 2 cosine minus 1 equals 0, or I know that the cosine of x minus 1 equals 0. Okay? So over here, cosine equals 1, so what's x?
0 is pi over 2.
Okay? 0 or pi over 2. Now this one, yeah, it didn't give us an interval exactly. So you can just assume it's 0 to 2 pi. Okay? Or wait, hang on. Cosine isn't 1. Yeah, cosine is 1 at 0. It's not pi over 2.
2 pi.
It'd be at 2 pi. Okay? And then over here, cosine would equal a half. So what would x be?
Pi over 3 or 5
Pi over 3 or what?
5 pi over 3.
Okay, what quadrant is 5 pi over 3 in? It's the fourth quadrant, okay? So we have first and fourth quadrant, cosine is positive. Okay? So any questions about this one?
No.
Alright. Now, 2 more here. Each one of these has another little nuance to it that I want you guys to be able to handle. Okay, so this one ended up with 4 answers. We had to get everything in terms of one trig function. Remember I told you though in our general strategy that we're going to get it in terms of one trig function if possible. Okay? Let's think about this one. We have cotangent of x times cosine squared of x equals 2 cotangent of x. So as you look at this one, what thoughts come to mind? What strategies come to mind? Get it equal to 0? Okay. Well, how would we get it equal to 0?
That's a plus. Is that cotangent plus cosine or times?
No, it's times.
Oh, okay.
I mean, you could subtract 2 cosine.
I mean, you can, yeah. Cotangent x times cosine squared x minus 2 cotangent x equals 0. Any other thoughts that you guys have?
Can you factor out?
Well, forget about this for right now. Going back to the original, what other thoughts did you have?
I would say make cotangent cosine and sine,
Okay, so if you did that, you'd have cosine cubed now over sine equals 2 times cosine over sine. Okay, that's not a bad idea. What else could you do?
Can you divide the cotangent?
Okay, that's another thought, is to take this and divide both sides by cotangent. Okay,
Oh, so you only get one cotangent.
and now you have cosine squared
It's 2.
equals 2. Okay, because these will cancel. All right.
Oh, I'm so smart.
Now, one of these you're not allowed to do. One of these would work, but it might get messy. And the other one is actually, I think, is the best solution. Okay?
We've got options at least.
Alright, so you have some options. One of them is not allowed. Okay, can anyone figure out which one would not be allowed?
Dividing because it's the easiest.
Dividing because it's the easiest?
No, you're not allowed to divide by.
Well, it actually is the dividing, but why is that one not allowed?
You haven't determined if it's equal yet.
What?
You haven't determined if they're equal yet? So okay.
Well, here we're solving an equation, so we're going to force it to be equal by figuring out what x is. Or saying that there's no solution, okay? So that's not an issue in this case. You are allowed to do this stuff. What? Someone said something, or started to say something.
It's because you can't cancel terms.
Okay. Let's think about this. If I had, say, 5x squared equals 2x. Alright? Back to algebra 1 stuff. And they told you, do not divide by x and make that 5x equals 2. Why couldn't you do that?
X could be 0.
Okay, right there. X could be 0. And if I'm dividing by x, then I just divided by 0, which would make it undefined. Alright? The other thing is here too, not only can x equal 0, look at the original equation. 5x squared equals 2x. 0 is a solution of that equation. Alright, so I know x actually does equal 0. Alright, in this case here, if you think about it, when cotangent equals 0 would be a solution to this equation. Alright, because 0 times cosine squared will equal 0 times 2. Right? So, I'm not allowed to divide by cotangent because I'm dividing by 0. The other thing is, again, going back here, how many solutions does this equation have? 2. How many solutions does this equation have? 1. So when I divide by my variable, I end up changing the degree of the equation and losing a root. Okay? So not only are we dividing by 0, but we also end up losing an answer if we try to do it that way. Okay? Oops. Now, both of these methods would work eventually. Okay? However, this one is going to be a little bit more complicated to get to. And in fact, in order to eventually solve it, we'll end up undoing what we just did. Okay, we'll actually be turning it back into cotangents eventually. Alright? So, while this is not incorrect, it's just longer than what we would have to do. Now, Eddie said this earlier. What did you say we should do next on this one? Factor. We can factor out a common factor of cotangent x. And notice, while I still have two different trig functions, because it's factored, and each factor only has one trig function in it, I can now look at it as, okay, well, either cotangent of x is 0, or cosine squared x minus 2 equals 0. And I am able to solve each of those. Okay? So, you can leave it in terms of different trig functions if it's in a factored form like this, and you only have one trig function in each one. Okay? Does that make sense? Okay. So, at this point now we just have to solve it. Cotangent of x is 0 when tangent is Okay, tangent of x is undefined. Where is tangent undefined?
Cosine equals 0.
When cosine equals 0. See how we're just kind of thinking through this logically? Cosine of x has to equal 0. Where does cosine equal 0?
0 or 2 pi over 3.
No,
Pi over
pi
2
over
over 3 pi over 2.
There we go. Pi over 2 or 3 pi over 2. Okay? Sine is 0 at 0. Okay? So cosine is 0 at pi over 2 or 3 pi over 2. Alright? So those are a couple of our answers. If we figure this one out, we get the 2 on the other side and then square root, right?
Yeah.
So cosine of x would equal plus or minus the square root of 2. So where is cosine positive or negative square root of 2? Okay, cosine does equal root 2 over 2 at pi over 4. Where does it equal root 2?
No solution.
Why?
Um,
It's not on the unit circle?
Yeah, use calculator.
How I know it's not just like one of those points that we didn't look at?
it's, you said these are based on unit circle. Well,
Yeah, but
Just assume.
come on, there's actually a clearer answer here.
Wait. What did you say?
How come there's no solution? You're right, there's no solution. Okay? There's no more solutions to this part. But why?
Because cosine
It's because tangent is undefined, so that means cosine equals 0. Right? No? Okay.
Oh.
Okay.
Cosine equal, right?
Uh,
I was close.
well, I mean, cosine equals 0 for this part over here.
Oh, that's fine.
But we can look at the two parts independently.
could be less than 1.
Come on, think. What do we know about cosine?
Less than 1.
What?
Less than 1.
Or more.
Okay. What is the square root of 2? Do you guys know?
No, it's top of my head.
1.414, okay?
And then, yeah,
So,
cosine's no bigger.
what do we know about cosine? Cosine goes from
Oh,
from
negative 1 to 1.
negative 1 to 1, okay? This is why we gotta know our graph of cosine. It goes from 1 down to negative 1 and then back up to 1, okay? It's never gonna equal 1.4, okay? So, there's no solution from that part. Now, that doesn't mean there's no solution for the equation. It just means this factor, cosine squared minus 2, is not going to give us any more solutions. So our final answer will just be these ones right here. X is pi over 2 or 3 pi over 2. Okay? So watch out for those. That is possible. Keep in mind your domain and range for sine and cosine and tangent and all that stuff, okay? You know, if you had cosecant equal to a 1/2, well, cosecant's never going to equal 1/2. So, you know, you can identify cases where there's no solution. All right? All right. One last one. When you can't get it all in terms of one trig function very easily. Okay? Here we have a case. Find all the solutions of cosine plus 1 equals sine over the interval from 0 to 2 pi. Okay? Sine and cosine are related to each other in an identity. Which identity is that?
Cofunction or Pythagorean.
Okay? Cofunction or the Pythagorean. Okay? And in this case, the Pythagorean might be a little more useful. We have sine squared plus cosine squared equals 1. The only problem is what? They're not squared. Okay? So since this is an equation, what can we do?
Maybe multiply both sides by sine or something, or square or
I like your second option there better.
square.
Let's square both sides. Cosine of x plus 1 squared equals sine squared. How did that help us?
Oh,
Yes, it did.
Sine squared equals 1 minus cosine squared.
We can FOIL, alright? So you have cosine squared x plus 2 cosine x plus 1. What can we do with the right side?
1 minus cosine squared.
We can make it into a cosine. 1 minus cosine squared. Alright? Now we're back. We have everything in terms of one trig function. We can get it equal to 0, factor, get our answers. Okay? So, go ahead and finish that one. Alright? Get it equal to 0. Get it equal to 0, factor it. Get your answers. Don't quit. You're not gonna be able to do this whole thing in your head.
I got this.
Come on.
no, that one.
I got it.
Okay. So there it is factored. So either cosine equals 0, right? Or cosine equals
1.
cosine x would equal
-1.
-1. So let's think here. Where is cosine 0? Pi over 2 and 3 pi over 2. Where is cosine -1? At pi. Now, one thing that we have to do in this case, though. When we squared the equation, what did we do to the equation?
Gave it another answer.
Oh, we squared the answers basically.
Okay,
So you have to take the square root of those.
nah, we didn't square the x's. We squared the values, but
We squared the cosine of
mm-hmm.
it. So
What? What'd you say, Hunter? Let's think about this. If I have, x equals I don't know, 3x minus 5. If I were to square both sides of this equation, not that that would be a good idea, but let's say I did. How many answers does this equation have? 1. How many answers does this equation have?
We had an extra answer.
2. We added an extra answer here.
So basically, you have to find out which answer is extraneous.
We have to figure out which one, if any, are extraneous. It's possible that all the answers we got could work. But what we'll do is we'll test these. Now, what I would recommend doing is you can make yourself a little table pretty easily. I'm going to do pi over 2. I'm going to do 3 pi over 2. And I'm going to do pi. Okay? And in this column, I'm going to do the left side of the original equation, cosine x plus 1.
Gotcha.
And on the right, in this column, I'm going to do the sine of x. Notice I'm using the original equation. Don't use these, because that's after you squared it. Alright? So use that original equation. So, what's cosine of pi over 2?
0.
0. So 0 plus 1. What's sine of pi over 2?
1.
1. So that one works.
Yay.
Okay? What's cosine of 3 pi over 2?
0.
0. So 0 plus 1. What's sine of 3 pi over 2? Negative 1. So that one does not work. Okay? Now let's try the pi. Cosine of pi is
1.
Negative 1.
negative 1 plus 1 is 0. What's sine of pi? 0. So that one worked. Okay? So notice here, our solutions are only pi over 2 and pi. Alright? Anytime you change the degree, we introduced a new solution when we changed the degree of our equation by squaring both sides. Okay? So anytime you do that, you need to check your final answers and make sure that you have all valid answers for the original equation. Okay? Alright, so at this point, I want you to practice some, okay? I've given you a couple different sections of ones to practice, okay? Notice I've modified the directions a little bit on these. You don't need to use the table feature or the graphing utility to check your answer, okay? You don't need to graph these and try to find the solutions with intersections. You guys already know how to do that, so, okay? But use your identities, use what we've talked about today, look to factor if you can, try to get it all in terms of one trig function, all of that to solve these, okay? So, the remainder of the time is yours, so use it wisely, okay?